Thank you, Mark.
Cheers.
It's true. I do actually really like doubling mean time. And for those of you that aren't familiar with it, it existed in the 1900s, and it was 25 minutes and 21 seconds before GMT. Like, not 15 minutes, not half hour, not an hour. The Irish thought, you know what, we're on our own time zone, it's 25 minutes and 21 seconds ahead. It's actually to do with trains and travel and the position of the sun. It's quite interesting if you take a look at it. But we're not here to talk about the Irish, we're here to talk about API standards. I hope you're all doing all right, you're having a good day. You enjoyed Juliet's quiz? No? Yeah. Also evaluating your career options, yes? Thank you for coming along to learn about API standards with me this afternoon. And when I give a talk, I try and find a bit of a story to lead through all of the points, but I really struggle with this one because it's more of a collection of ideas than a cohesive story. Because building an API isn't necessarily something that you do sequentially. You might do a bit here, a bit there. Oh, I forgot this bit, let's add that in. There is a checklist of things that you need to run through at the end, but a lot of the work can be done in any order. And with that in mind, I want to start today at what I think is the most logical part of building an API, right at the end, with API deprecation. You're about to build an API. When you build it, you ship it. People are going to start building on top of that. And we have no idea what they're doing with that API. Some of these people are going to depend on this API for their livelihood, so we need a way to tell them when we're making breaking changes, when it goes away. And API deprecation isn't something that happens many, many years in the future. You could end up deprecating an API just a few weeks after you ship it. You might realize actually the data model doesn't work as we expected, or it doesn't scale, or maybe just the use case shifts a little bit. It's not like you have to build an API and keep it running for 10 years. It could be gone within 6 weeks. And with that in mind, your API should be versioned from day one. And we'll talk about versioning a little bit later in the talk. It should be versioned, it should have a clear deprecation policy for all APIs, even beta APIs. And at this point, you'll typically have a low number of beta testers, so you can communicate any breaking changes to them directly. You'll have their email address. You might be meeting them regularly. Next up, you launch. It's official, we shipped. And at this point, you need to support your API for any existing integrators that you've got. And this is true for both cosmetic changes. Well, we used UUID as the field name, and actually, it's not always a UUID. Let's just rename it to ID. That's a breaking change. Even though it just feels cosmetic, it's not. And then we might have larger changes, like changing the underlying data source. And at this level, we need to be tracking API usage on a per account level and have a way of communicating these changes to your customers. Usually, we can work out who's using which API through API keys or authentication tokens or anything like that. And we can tie that back to an email address. So when you're not holding people's hands through the beta process, the best way to get in contact with them is with a direct email. Hey, we noticed you're using this API. It's going to change in this way on this date. But no matter how much you warn them, people are going to complain on the day that you change it. Like, oh, I didn't see my email. Oh, I didn't realize that applied to me. Like, just brace yourself for support requests because people didn't read their emails. And then finally, we get to API retirement. And this one is a tough one because if your company's shutting down, there's not much you can do. Like, that API is going to go offline. But what if it's a business decision? Imagine, I don't know, you work for a telecoms company and you have two APIs that you use for sending text messages. One that was built 8, 9, 10 years ago that doesn't really follow standards. If there's an error, it still sends back 200 OK. Completely theoretical. But imagine that you've got that API and you've also got this second API that you can use for sending text messages, which is fantastic. It meets all the new standards. It uses great errors. Can you turn off the old SMS API and just say, everyone go to the new one? In my opinion, you should never turn off the old one, because at that point, you've got almost 10 years of existing integrations with a huge number of messages being sent every single second. we still offer the functionality that the old API provides, just in a shiny new wrapper. So, in my opinion, we should keep the old interface running as well. If it isn't broke, don't fix it. People don't upgrade the version of the API they're working with very often, because if it's still working for them, like, where's the business value? Like, they're not going to upgrade just because you ask them to. There has to be something in it for them. When you're retiring APIs, have a deprecation policy. And it doesn't matter what it is, just have one and be consistent. This is the next mode deprecation policy, taken from our developer documentation. We provide 60 days of notice for beta endpoint changes. Officially it's 30, but we try and be a little bit nicer and say, hey, you've got 60 days to change this before that endpoint goes away. And we provide 12-month notice for all other endpoints. We communicate to customers using our documentation. If you go to the API docs, there's a big banner saying, hey, this is changing, here's the new docs. And we send emails to our active customers. If you want a more passive way to communicate these changes to customers, there's a fantastic header that you can use called the sunset header. This is a great low-touch way to communicate deprecations to your consumers. Anytime they make an API request, they get this sunset header back saying this API is going away on this date. And what's even better is if you're consuming these APIs using PHP, using Guzzle, and you're using a PSO3 compliant logger, there's a library out there. It's a Guzzle extension. You give it a logger, you add it to your Guzzle stack, and anytime it encounters a sunset header, it logs it out for you. This will keep you informed of any API deprecations for any services that you use, assuming they're using the sunset header. So, we started at the end, we built an API, we know how to shut it down. After that, versioning feels like a pretty good place to go. Because after all, you can't deprecate an API without it being versioned, unless you just want to turn it off entirely. Now, versioning is one of those things that looks really simple, but it really isn't. According to Roy Fielding, who wrote his dissertation on REST, that's where the term REST came from, we should never need to version an API, as we'll all use hypermedia to navigate it. I love this quote. The reason to make a real REST API is to get evolvability. A V1 is a middle finger to your API customers. Like, it's quite a strong statement. What is wrong? Because pragmatically, you need to version your APIs even if you never intend to use it. It's having the option to break things and not needing it.
Wasn't he referring to each?
Yes,
Yeah.
he is.
So he's talking about the next level of REST there, really.
Yeah, so the question was, is it a next level, is it HATOS? So hypervention is the, hypermedia is the engine of application state. Thank you. Yeah, that's a bit of a tongue twister. Yes, that is what he's referring to. But when you change your data model in your database and you can't provide the same interface anymore, even if it's discoverable, that's a breaking change. And that's why I think Hiram's law applies a lot better. Because when a sufficient number of users of an interface, it doesn't matter what you promised in the contracts, every observable behavior is going to be depended on by someone. And having the option to break an API through versioning and not needing it is much better than needing it and not having it. So let's start with the contentious stuff. How should you version an API? Should you use an accept header? Should you use a custom header? Or should you put it in the URL? There are pros and cons to all of these examples, and for a long time I was fairly dogmatic. It's an accept header, that's the right way to do it. It's not a part of the resource, it's a representation. Now I'm a lot more pragmatic, because when I was building internal services with a fantastic team of developers, we all understood the accept header. When you start working with normal customers, like, if they can't see it, they don't understand it. So I'm a big fan of just putting it in the URL. They know they go to /v3, they get version 3 of the API. It makes it obvious what they're getting, and it reduces the barrier for junior developers. Now, when it comes to versioning endpoints, there are a couple of ways to do it. You can version endpoints globally. So api.nextmore.com/v1, and then we've got calls, media, messages. But this only goes so far. In this example, if we needed to make a breaking change on any of our products, we'd have to increase the version of all of them. So you might choose to version them independently. We chose to do this to make our lives a little bit easier, but it does slightly increase complexity for consumers. They need to know which version of which API they're using. Now, there are a couple of different options available for versioning APIs, and Nextmore we chose to increment version numbers as we try our hardest not to break backwards compatibility. That means that we're not releasing 10 new major versions a year. We want to hit version 173 at some point next year. But sometimes you can't offer those stability guarantees. Like if your data model changes quite a lot, if you depend on external companies for that data, and it's constantly changing. So if you do frequently need to release breaking changes, another option for versioning is to use the date. And this allows you to release as frequently as you like without having huge version numbers. Now, this 2010-04-01 is actually the most recent version of the API for the provider. They haven't changed it since 2010, but they were aware that they could have made breaking changes fairly regularly, so they chose to go for a date-based versioning scheme. And then the final option is to use semantic versioning. I can't really recommend this, as your consumers don't care if it's a patch or a minor release. They don't care that you added a new feature, so long as it doesn't affect them. All they care about is major version changes, breaking backwards compatibility. Semver doesn't really work for API versioning, as an API is an interface, not an implementation. I ran across this interesting idea fairly recently. It's called version variants. And when developing a new feature, instead of adding it to an existing version, you create a new version that includes that feature, e.g. v3.new-feature. And the same rules apply as normal versioning, additive changes only, no backwards compatibility breaks. You could have new feature.1, new feature.2, new feature.3, which can have backwards compatibility breaks. And what I like about this is that it's explicit. Requesting a variant, it's an explicit opt-in from your customers, and that allows you to communicate that it might not be held to the same high standards as the rest of your API, that it might change. It doesn't provide the same stability guarantees as your main API. And it also gets people to upgrade, because if they want v3 new feature and v3 banana, they can't have both. They've always got to come back to mainline before they can try the new feature again. I've never actually seen this used anywhere, but I thought it was an interesting idea, so I want to share it with you all. So, we've decided how to version our API. I'd use the URL. We can start building it now. And I'm not going to spend too much time on common wisdom here. We all know, let's use HTTP verbs, but there are some useful, less common things that are worth sharing. We'll do a quick run through of the verbs, just to make sure we're really clear. We'll start with get. And we use this to fetch resources, and it should be idempotent, which is a really fancy way of saying that it doesn't change any state, so we can make the same request over and over, and it will always have the same result. This is important. This is really, really important. In fact, it's so important that I have a little story to share with you involving GET requests and the garage door. This is from a gentleman called Will Pierce. Now, Will added a Wi-Fi control to his garage door. He got a little adapter motor, and he ended up writing his own interface for it. So he installs this in his garage door, and he built a little web interface /toggle, but he was a little bit too lazy. He couldn't bother to work out how to make it respond to post requests, so he said, yeah, it's fine, I'll make it a GET. That was his first mistake. Now, Will use this page a lot, and he's in the Apple ecosystem. He used Safari, and Safari realized that Will was going to this page a lot, and started adding it to his home screen. Hey, you use this a lot. I want to put it where you can just press it in one tap, which is useful. But then Safari started to sync that across all of his devices, his phone, his laptop, his iPad, which means that any time he opened a new tab, his garage door opened or closed. Didn't matter what time of day, what device he was using. Every time he opened a tab, it showed all the previews, it did prefetch, and his garage door opened or closed. And that is why GET requests should be idempotent. That's the original talk. That was just too good not to share. So there are a couple of options when responding to a GET request. The most common is a 200 OK with a response body. But you can help out your customers by being as specific as possible. For example, if they're asking for XML and you only provide JSON, don't just respond with JSON. Send back a 406 not acceptable response until they update their accept header. Post can be used for a couple of things, and in a perfectly RESTful world, it's used to create a resource. Practically, we use it to trigger RPC-based APIs as well, which again we'll cover later. And I'm not going to list out all of the possible codes for Post, but there are a few really useful ones. And my first big ask is that we don't use 200 OK for Post. That's not a valid response. Use 201 created if it's a synchronous response, and 202 accepted if it's asynchronous. If it's a job that you've accepted and you'll process later. If you send back 202, you need to either send back a location header that the user can query for the job status, or use webhooks to notify them when it's done. As far as errors go for Post, 415 and 422 are good to know. 415 is when they send the wrong data format. For example, if you're JSON only but they send form encoded data, you don't understand how to process that. Send them back a 415, we don't support that media type. And then finally 422, unprocessable entity. Most people use 400 for validation errors. It's okay, but it's not quite accurate, because 400 is really for invalid payloads, such as malformed request syntax, or request framing, if you've got any WebSockets or anything like that. If your server can understand the request, but not fulfill it, that's probably a 422 unprocessable entity. Put is used for replacing an entire resource. It shouldn't be used for partial updates. And it should return a 200 with the new resource in the response, or a 302 pointing to the new resource, or the updated resource. And delete, well, delete removes resources. So once it's deleted, there's no resource to show anymore. So I think 204, no content here, is pretty good. Which brings us on to a really interesting one, which is patch. Now I mentioned that put shouldn't be used for partial updates. You should use patch for that. It's been around for a while, but it wasn't really adopted for a long time. But it's become more popular recently, as it does have those partial update semantics that put doesn't. In fact, I recommend to our teams that if you've got to choose between patch and put, build in patch, because you can do everything with patch that you can do everything with put that you can with patch. Other way, let me start that again. You can do everything with patch that you can with put, but patch also supports additional things like partial updates that put does not. Now, the nice thing about patch is that there are standards to choose from. And yes, I said standards, as in there are multiple standards, which is always nice. The one that most people use, and usually without knowing it's an RFC, is JSON merge patch, RFC 7396. Sending this request will update the user's name to Michael and remove line 2 of their address. A competing standard, just called JasonPatch. Instead of a document, you send a set of operations to perform on the document. This is how we'd achieve the same update as the last slide, using JasonPatch. We use a replace operation for name and a remove operation for line 2 of my address. Replace is just a helper method. It's actually the same as doing a remove, then an add. I'm not a fan of this one. I much prefer JSON merge patch. That's how most APIs work nowadays. Now, when people think about resource design, they think about how to respond to a GET request, but there's so much more to it than that. Your URI is a part of an interface, as are out-of-band requests like webhooks. When we're modeling RESTful resources, we should use a noun. It should be a plural. If you're working with a specific instance of a resource, the identifier for that resource should be in the URL. I think that's fairly commonly accepted. That's how we build APIs today. Something that we don't tend to cover, though, is sub-resources. And sub-resources are endpoints that are nested inside another endpoint. And sometimes it makes sense to create sub-resources for filtering. For example, we have the ability to fetch a user. We want to see all of the calls that that user's placed. So we create a sub-resource of calls. And then if we want to fetch information about a specific call, we don't just keep going. As soon as you start nesting these sub-resources and adding IDs and IDs, it becomes a top-level resource of its own. Because at this point, there is enough identifying information with just the call ID. You don't need user as well. Sub-resources, in my opinion, are usually just a helpful alias for a common query. This request, for example, can be expressed as a filter on the calls resource. I want to see all calls placed by user ID 1. And as with everything, there are exceptions. You may have a user concept and an address concept. But you can't say users 1, addresses 33.902.10, and then say, actually, I just want that address because there could be multiple users living at that single address. Like, that combination of user and address is the unique identifier. So at that point, you may choose to define a new resource type, user addresses, and take that back up to the top level. It doesn't really matter which you use for this. I prefer creating the new resource with the compound ID. But whichever you choose, be consistent. The other hard problem in URI design is action endpoints. You know the ones where you need to perform an action on a resource that's hard to model, like shutting down a virtual machine. And you may be shocked to believe that no one can agree how to model this. Like, this is a live counter. There's currently about 200,000 different ways of doing it. Some people treat it as a direct sub-resource. Some people just say, OK, machine ID 1, I want to shut down. Some people have an action sub-resource and then have the action after that. Some people prefix things with action to make it clear what's happening, and others have generic actions endpoints they post values to. Please don't do the last one. It makes it really hard to document, use, log, everything. But the others, doesn't matter. Choose one, stick to it. Consistency is the theme throughout this talk. Some people really don't like the idea of action endpoints, and they model everything as a resource. And this works, but it can add quite a lot of complexity to your API. Personally, I like it because it adds an audit trail to your application. So if we wanted to say, hey, when was the machine shut down? We can see all the post requests to machine shutdown. That becomes a state change. If we want to see an audit log of all of that, we just add get machine shutdown, and that will show us all of the entries in the log for when the machine was shut down. And the resource model works for all kinds of things. Locking a resource, transferring a balance from one account to another. It takes a little bit of thinking about your models, but it is possible. It doesn't matter what you decide to use for representing your resources, but you should be consistent. And here's a snippet from the Nextmongo API guidelines. Not only do we specify that we use snakeCase for our responses, but we provide rules for common tasks such as defining a webhook URL and the method to use when calling that. Common field names like start, end, and any references that are required. And those standards should extend to your webhooks. If you have a representation of a resource in your API, don't use a different representation in your webhook. Keep things consistent. Use the same naming conventions, the same data structures, and follow the same rules. We currently use snakeCase in our API and camelCase in our webhooks. So I'm throwing stones from a glass house here, but we're working on it. We're working on normalization, but that is a breaking change for our customers. So we can't just decide overnight we're going to change it, but we are working towards being consistent. So now we've got an API, it's versioned, we've got a URL, it works. We can then interact with it, we start adding resources. It's time to start adding some error handling, because so many of us just build happy path APIs, and then when it doesn't work, it really doesn't work. Errors are easy. I can hear it all in your heads now. Like, just use status codes, people know what's happening. 200's okay, 400's validation, 500's that I did something wrong. If it's 401, you forgot to add authentication details. Well, either you forgot to add them, or you provided the wrong ones, or you provided ones that were previously valid and now they've expired. It turns out that a single status code can be used for lots of different problems. Which would you rather see when integrating an API? A response that just says 401 unauthorized? Or a response that says, hey, you forgot to provide your credentials? Or, hey, the credentials that you provided were invalid? And wouldn't it be even better if you got this message, instead of just telling you what went wrong, it told you where to go to get more help? The credentials you sent were invalid. Here is more information, deep linked to that specific error. Now, people have been returning errors in the response body for a while, but each person doing this does it slightly differently. Instead of our error formats being predictable, like HTTP codes, each time we implement a new API, we have to read the documentation, work out what each error code means, add that into our application. We had to consult it. We had to consult the documentation to work out how to work with the errors as well as the API. Then in 2016, RFC 7807 was proposed, and this is the problem details for HTTP APIs, RFC, which defines two new content types for returning error messages: application problem plus JSON and application problem plus XML. And no matter which format you use, the keys are the same. And each error that follows this RFC has the same keys, each of which has a specific meaning. The only required field is title, because if type is not provided, it defaults to about blank, which tells people to look at the HTTP status code. There's one field that isn't on here, and that's status. It's optional, and it contains the HTTP status code. This can be useful if an intermediate proxy changes the code, but in practice, I've not actually found any use for it. So taking these four keys, we can create a consistent error format for people to consume. And it looks like this. And this is a real Nextmo error message. We do break the RFC a little bit at Nextmo, because in the instance field, we put our trace ID. This is a field that we already had, and it's what we use for debugging. Someone says, hey, there was an error, this is my trace ID, and we can see that all the way through the logs. RFC 7807 says that should be a URI, and it's obviously not for us. But as the instance URI was never intended to be followed, it was just an identifier, we felt that this was an okay trade-off to allow us to start adopting standards. And the RFC understands that those 5 keys might not be enough for everyone, so they've allowed extension members too. Take this example from the spec. Trying to parse the detail message to find out the current balance is 30, and the item that you're trying to purchase costs 50. Like, trying to parse that out is quite tough. So they added 2 extensions: balance, which shows the account's balance, and accounts, which gives links to where the account can be topped up. The only use case we've got for this at Nextmo is validation errors. In this case, we send back an invalid parameters key in addition to all of the others. And we send back this key every time there's a validation error across all of our new APIs. Always in the same format, always a list of objects, name and reason. This has allowed us to provide a consistent interface for our API consumers. But not only is it a consistent interface, we're actually starting to send back consistent errors as well. Like, we built up a list of error cases that we can use. If someone comes along and says, hey, Michael, I've got a 401 where they provided invalid credentials, what should the error look like? We just go to our error library and say, there you are, 401, invalid credentials. And it means that no matter which of our APIs you're using, you get the same error message whenever you encounter the same error. It's not invalid credentials for one, bad credentials for another. It's a consistent error message in a consistent format. And even though the RFC says you can use about blank, and to imply that the HTTP code should be respected, we like to return the same format for everything. And so always a type, which always contains a link to our documentation, which means that we define errors for things like 410 gone and 500 server error that don't really need more explanation, but we do it anyway just for consistency. And this really is worth it. So this is a quote from one of our client library maintainers. As a consumer of the APIs, this has already dramatically reduced the amount of code I have to write for each endpoint, and I can't wait until all of our endpoints are standardized. This is an internal person that builds one of our client libraries that we give out to customers. But that's just one person that's been interacting with it. Think about all the people that you don't normally hear from that normally have to integrate your APIs. They're probably thinking the same thing. Now, I keep talking about consistency, both with resource design and errors. And this is hard to achieve in businesses where multiple teams work on multiple products. Even if they follow RFC 7807, they may use different words to explain the same error. And by designing your APIs before you start building, you can catch a lot of these issues and start building up a catalogue of these reusable building blocks. For example, I've been working on an API specification this week. And instead of declaring every error in every endpoint, we have that library of shared errors. It's really nice to say, okay, this endpoint has its own 400 error because it's got a specific validation error. But it uses our common 401, 405, and 406 error definitions. And this is nice because it means that when people go to our documentation, they can see every single HTTP code that endpoint could possibly return. They don't have to guess. It's all up front for them. And actually, it's even better for our engineers because how many people on your teams would think, actually, I should probably add a check here to make sure that if they send a content type of XML, I don't just try and process it as JSON. I need to send back the right HTTP code. Like, a lot of people don't think about that, but when you give them a specification like this, say, oh, 405, 406, I need to make sure that I handle those in my code. Like, the documentation becomes the design. And this all gets rendered nicely by any standards compliant documentation engine. This is Redoc. It's one of the more popular rendering engines. Highly recommend taking a look at it. And all of this is made possible thanks to the Open API initiative. There's a whole other talk about API first design and Open API spec. Come and talk to us at the Nexmo booth later if you want to learn more about that. We both do it quite a lot. But I wanted to mention it as it's helped me build much more usable APIs for our customers, having to think about things up front, like making conscious decisions about what we're going to build has had a real impact. And when you define your data types and then build an API using those components, it makes life easier for your consumers as well. We're PHP developers. We can deserialize JSON absolutely fine. Like, we get arrays of arrays of arrays. But we're building APIs here. Like, our customers might be Java developers. They might be .NET developers. They might write Go. Any other language with a type system. Small inconsistencies in your API responses can add up to a lot of additional deserialization work. If your field is called ID in one representation and UUID in another, but all of the other fields are the same, it's fine for us as PHP devs. But for Java devs, that's 2 deserializers. That's twice as much work. And catching that early, it just can't be underestimated how much better it makes the experience for those consumers. Right, it's time for collation management. And this is one of my favorite parts. Everyone does it differently. Collation management is actually 4 different sections: sorting, filtering, searching, and pagination. I'm going to spend a very short amount of time on each. Let's start with sorting, as it's the easiest. You get an API, people say, okay, sort by sort direction. Fantastic, job done. I can now get all the users sorted by email address ascending. But this has an issue in that whilst it does what you wanted, you can only sort by one field. So say, okay, maybe we combine those. Maybe we sort by email ascending. And now we can filter by multiple columns. Sort by email ascending and by status descending. But doing it this way is tricky as well, because when you repeat parameters, there's nothing in the HTTP spec that defines what order they have to be processed by the engine. So here, we could get it ordered by status descending then email, or by email then status descending. So we combine them. We make it a single parameter with a comma-separated list. The essential is that the ordering is preserved. We always get email ascending followed by status descending. And then finally, we can replace ascending and descending with a plus or a minus. And maybe we have an implicit positive and an explicit negative. It makes it nice and terse, but I'm not sure that I like it. It's not as readable as the explicit email.ascending, status.descending. We don't actually have any guidelines on this at Nexmo yet. So I'd love to talk to people afterwards if you've got any opinions on this. You can help us decide, do we want the terseness, do we want the readability? Do you have any previous experience with other APIs? So if you come along and say, everyone does the second one, Michael, like why are you even considering the first one? That is useful. Which brings us on to filtering. And there are two types of data that you need to filter on. Discrete data that has a finite set of values, and continuous data like a timestamp, which could be anything. And for discrete data, allow the user to take the parameter name, add it as a query parameter, and then put any value there, and then just do a lookup on that. Anything in the response body, allow them to filter on that, like make it intuitive for them. Sometimes you don't want to do that. Sometimes you might say, actually, you can filter on most of them, but this one field, like I don't really want you filtering on that one. But if that's the case, don't just say, oh yeah, you can put it on and we'll filter on the field for most of them. But if you put that one in, we're just going to ignore it and return all the data. If there's a business reason not to allow filtering by a specific field, make it return a 403. You are not allowed to filter by this field. Like, make it explicit. If we take a look at JSON API, they use a filter parameter on collections. But honestly, I think that using each key as a parameter is just that little bit cleaner. It feels a little bit more intuitive for our consumers. It's easier to read. Moving on, we have continuous data. And we need to be able to search for ranges when the data doesn't fit nicely into a small set of options, like admin, user, band. Like, try searching for a specific timestamp, for example. Now, a typical example is searching for orders placed between two dates. Taking our decision to use the resources key as the filter name, we can make each parameter an object. So instead of start underscore date and end underscore date, which is a dash there, typo in my slides, if we wanted to filter on another continuous field, we'd have start underscore field, end underscore field, and that can just explode. Instead, if we take a lesson from our discrete filtering, make the parameter the name of the field, make it an object. And this provides flexibility to search where the value is greater than or equal to, less than or equal to, or if the value is exactly equal to the filter provided. Because by passing in the key in the object, so here we've got date GTE, greater than or equal to, we can change that to EQ for equals, LT for less than. One parameter, lots of filtering possibilities. Whereas with start date and end date, you didn't have any of that control. One thing to mention is that industry standards do exist for this kind of thing. So check if there's one available before developing your own system. If you're building an identity management system, for example, you probably want to look at the RFC focusing on systems for cross-domain identity management, SCIM. before creating your own filtering system, because they've got a pretty comprehensive one. And even if you're not working in the identity management space, it's worth having a read just to get some ideas. And sometimes basic filters aren't enough and you need the power of full text search. Perhaps you're already using Elasticsearch or another Lucene-based technology. If you're performing search, the query parameter is normally called Q, and it should accept any string that is passed to it. It should take any string that's passed to it and send it directly to the search engine. And it's up to the engine to reject with any errors if it's invalid or anything like that, which should be returned in RFC 7807 format once it passes back through your application. Or return any data, which should be in the same format as any other request to your endpoint. This is the most flexible option for your API consumers. It's a lot more than ordering and filtering. You've got a whole search syntax, but it is much harder for beginners to work with. You need to become familiar with Lucene syntax. It requires percent encoding in the URL, which makes it more difficult when using curl. And there is a trade-off here. It's more powerful, but it's harder to understand and harder to use. Which brings us on to pagination. There are two types of pagination: offset-based and cursor-based. And offset-based is the most common. It's easy to understand and easy to implement. You take a page number and a page size, multiply them together, and then skip that many rows before you start returning data. So, select from users offset 300 in this case. It's reasonably straightforward to get started with. But it's not a performance solution for large offset values, because when you're using offset, your database needs to scan and count rows starting at 0. So if your offset is 10 million, that means it's going to scan 10 million rows and throw them all away before it starts returning data. The other issue with offset pagination is page drift, because if new items are inserted or old items are deleted, you may end up counting the same item twice or missing an item altogether. If you've got 21 items in your database, you're fetching 10 at a time. I fetch 10, I fetch 10. The next time I fetch 10, I should get one item. But if between you fetching the second time and you fetching the third time, someone deleted an entry, suddenly you've only got 20 now. When you do offset 20, that item's gone. Like, you never see that value. This is especially noticeable when you're ordering by items by newest first, because every time you get a page and then you go to the next page, but you've had a new item and it goes to the beginning, you're counting something that you saw on the last page. That's what makes it really obvious that you're doing the double counting. The other option is cursor-based pagination, also known as the seek method or key set pagination. And this is slightly harder to implement, but it is much more performant and much more reliable. Items are sorted based on an orderable column, usually a timestamp or an ID or something like that. And when you return a set of results, they take the highest value from that column and provide it to the next request. This doesn't work too well with low cardinality fields, and it's safest to order by at least 2 fields internally to provide consistent ordering, but it is highly performant, as instead of using offset, this actually gets converted to a where. So, show me all calls where the correct start time is greater than the 19th of the 1st, 2018 at 33 minutes past 12. You can make it even easier for consumers by giving the next page's link in your response, either in the body or as a link header. This is really useful when using cursors, but it's also useful when using offset pagination. That way the user doesn't need to think, okay, what value do we need to pass in to the URL for my next request? They just follow the link that's there. Speaking of links to the next page, let's take a look at hypermedia. Our API is looking good, but it's time to make it more discoverable without docs. Let's add some hypermedia, and our chosen style is how.json. We have a list of applications, and if I want to get that application, I need to know how to construct the URL for this instance. With hypermedia, we add this _links section, which contains a pre-constructed URL that the user can follow. And this is where most people get to with hypermedia. Okay, I added a self-link. And then they stop, and they wonder why they're not getting much benefit from hypermedia. This doesn't actually have much. Where it gets really interesting is when you start thinking about relationships. For example, I have this application, and at Nextmo, you link phone numbers to applications. So wouldn't it be great if you could say, hey, fetch my app. Actually, I want to see what numbers are linked to this. That's where hypermedia comes in useful. You look at links, you look at numbers, and it gives you the URL that you need to call to get all of the numbers associated with that application. How about adding a relationship for webhook configs, audit logs, anything related to this application can go in this, and it makes your API that much more discoverable. And this is a good start, but it's just a URL, and it doesn't tell you how you can interact with it. As it's an object, I've seen people add hints on how to use it. This isn't a standard format within HAL, but it is taken from the home documents for HTTP APIs draft spec, which means although it's not a standard, it is based on something that could become a standard. And this allows you to specify what formats are available and what verbs are possible on that endpoint. And with that in mind, a full hypermedia entry could look like this. There's quite a lot in there, but it's documentation that every single user will see. There are bandwidth implications. So if you're sending tons of traffic, you might not want to put all of this in there. So you need to do what's best for your use case. If bandwidth is a concern for you, there are lots of options. gzip is pretty great. But my first port of call today will be rate limiting. And I get this asked this question a lot. Should we add rate limiting? Yes. That's the short version. Rate limiting is a key part of any production API, in my opinion. It should be done at the earliest point possible, not in the development process, but when the request is received. And that typically means it's done using an API gateway, such as Envoy, at the edge of your network. And rate limits can be used for all kinds of things, from billing, you pay us more money, you get better rate limits, all the way through to platform protection from either malicious or perhaps just incompetent users that don't realize just how hard they're hitting you. You have a couple of options when it comes to rate limiting. From easiest to hardest, we have per server, per region, and per user. Per server is the easiest because there's no shared state. Each server gets its own capacity. When it runs out, requests are rejected. That works okay, but it means that you can make a request and get rate limited, then make another one and have it succeed, so it's not really the nicest for your consumers. Next up is per region. That requires some coordination between data centers within a single region, but because they're quite close, latency isn't normally an issue. And then per user, which is the ideal, but also the hardest to implement. This is where each user gets their own rate limit, but this usually involves global coordination across products and data centers, which makes it pretty tricky to coordinate. If your request is taking 100 milliseconds, but you've got a data center in Singapore and a data center in New York, and that takes 150 milliseconds to synchronize, you're going to have a tough time with rate limits. So again, it depends on the constraints placed on you by your use case. So you've got rate limits. How do you reset them? Do they reset on the hour? And everyone gets 10,000 requests on the hour. So 1 second past the hour, you get 100 million requests. Is it bucket-based, where it replenishes one request every second up to a maximum? So you get 100 requests. You can burst 100, then they replenish 1 second at a time. And if you stop making requests, it will go back up to 100. Or is it fixed, one request per second, which means they either use it or they lose it? There are pros and cons to each, usually involving development and maintenance costs. But if I was to choose one, I'd choose the bucket-based approach, where they refresh every second up to a maximum value. That means people integrating can test fairly rapidly, but they're not waiting half an hour to an hour when they hit their rate limit. They just have to slow down their testing to once a second. Can we accept and queue requests? Instead of rejecting the request, return to auto-accepted and process it at our earliest convenience. This adds complexity for both us and the user, because we need to set up webhooks or polling endpoints or something like that. Plus, if it's a time-sensitive request, like making a phone call because the server's on fire, like it may be useless in 5 minutes. We don't want to queue that. We just want to reject it and tell them, sorry, we can't do that. Rate limits and queues are important. I wouldn't launch an API without them. And last but not least, the most important part of an API is documentation. Even if you build the world's most beautiful hypermedia API that's entirely machine readable, people still won't be able to use it. After all, what does MSDN org local remote mean in the response? Honestly, like, I wrote these slides and I can't remember what it means. Like, how are your consumers supposed to understand that? Write an open API specification. I mentioned it briefly earlier, but you can use it for generating documentation that explains how to use your API. Import it into Postman, start poking around, play with the API without having to configure the endpoints yourself. Or generate client libraries automatically, although in my experience this is still quite rough and needs a little bit more work. Write actual words to explain what your API does and what all the options mean. We offer text-to-speech services all over the world, so understanding what each available name actually means is pretty key. Like, I can go in and say, hey, use the Sally voice, but no one else knows that that's a US female voice. And then provide code samples that people can copy and paste to get started. Your API can be perfect, it might be the best API ever developed, but if people don't use it, then why does it exist? Documentation is key to helping people both discover your API. Yes, documentation is a marketing tool, and start integrating it. Which brings us to our conclusion. And it's not really a conclusion, as this talk is a set of tips, tricks, and trade-offs for you to take back to your own company and think about. My aim when building APIs is to be helpful. Use consistent representations of a resource, put the version in the URL. Like, pragmatism wins every time for me. And I want to emphasize that this is not a theoretical talk. This is what I've been working on day to day for the last 18 months at Nexmo, taking a set of APIs that feel disjointed, and adding coherence and predictability for our customers. Just out of interest, like, how many of you had heard of Nexmo before today? Quite a few. Well, hopefully now that you've seen how much care and attention we put into our APIs, you'll be a little bit more willing to go, give them a go, and see what you can build with them. If you've got any questions, feel free to DM me on Twitter, email me, or I'll be on the Nexmo booth for the rest of the day. And please leave feedback for this talk and every other talk you've seen today. Thank you.